All right, welcome future builders, mechanical innovators, and civil engineering tech students. Today's explainer takes your Beck's 30013 Engineers and Society syllabus and literally transforms it into an interactive, 3D animated roadmap. We're charting your real-world journey from an ambitious student to a licensed, world-changing professional. We aren't just going to sit here and read through course outcomes today. We're diving straight into the practical realities of your future career. So, what does it actually take to make that leap? To transform from a student into a pro who builds the future? Let's fire up our 3D render and explore the three core pillars of your profession. ESG frameworks, the technical crucible of the engineering design process, and finally, your professional compass. Okay, Module 1, the macro view on sustainability and ESG. We start by zooming way out to see how massive the social and environmental implications of technological developments really are.
Now, you've got to check out this 3P model because it is a total game changer. It proves that modern engineering isn't just about, building things that physically work. It's this intricate balancing act. You're measuring your success by profits, people, and our planet. If your mechanical or civil project ignores even one of those 3Ps, well, it's fundamentally flawed right out of the gate. As we rotate this concept in our 3D viewer, we expand those 3Ps into the broader ESG framework. That's environmental, social, and governance. Navigating these factors and aligning with the 17 UN Sustainable Development Goals, that's no longer optional. It's absolutely crucial. It is the baseline for engineering companies and the investors who are funding your projects. Okay, let's pause our 3D simulation for a quick interactive quiz to test your retention on this first module. First up, what exactly does the 3P model measure? Second, what does ESG actually stand for? And finally, what global framework should your projects align with? Lock in your guesses. Let's see if you hit the nail on the head. The 3P model, that measures profits, people, and planet. ESG stands for environmental, social, and governance. And those 17 UN SDGs are your ultimate global framework. Mastering these definitions is literally your very first step toward responsible engineering. Moving right along to Module 2, this is the engineering design process lifecycle, from problem analysis and presentations to design versus analysis, dealing with uncertainties, and finally, project planning and risk management. This brilliantly illustrates that your designs do not exist in a vacuum. Whether you're designing a high-speed mechanical rotor or a massive civil infrastructure bridge, you have to deal with uncertainties. Managing failure, ensuring safety, and understanding product liability, that is what keeps the public safe from catastrophic events. Time for our second interactive check-in. Visualize your CAD models for a second. Can you tell me the crucial difference between design and analysis? And secondly, why exactly must engineers obsess over uncertainties? All right, let's break it down. Analysis takes a complex problem apart to understand the physics, but design, that is the creative act of building the actual engineering solution. And you deal with uncertainties for one simple reason: to prevent failure and protect human life. That final step, meticulous project planning and management of risk, is what gets you safely to the finish line. Shifting our 3D view over to Module 3, the rules of the game. This covers professionalism and IP, acting as your professional compass. If you want to become a recognized professional engineer, a PN, you've got to navigate some pretty strict frameworks. In Malaysia, that means deeply understanding the functions of the Board of Engineers Malaysia, or BM, and the Institute of Engineers Malaysia, IEM. Plus, your degree is shaped by the EAC to ensure it meets Outcome-Based Education, or OBE, standards. I absolutely love this quote because it grounds us right in reality. Your career relies heavily on adhering to these fundamental canons. It's not just about what you can build, it's about what you should build. If a client asks you to cut corners on structural steel to save a few bucks, this code is your legal and moral shield to just say, no way. We are actually going to render some 3D case studies later in the course to simulate the intense ethical, moral, and occupational safety and health dilemmas you'll face. Imagine being a whistleblower who discovers a critical flaw in a concrete dam design, but management is pressuring you to stay quiet to save costs. That is where strict adherence to OSH laws comes in. People's lives literally depend on your integrity on that job site. But hey, beyond physical safety, you've got to protect your ideas too. Notice the strict legal distinction here between intellectual property types.
If you invent a revolutionary new turbine blade, you need a patent to protect that basic concept. But your brand identity, your software code, or your architectural drawings, those are protected by trademarks and copyrights. To maintain that IP and hit your ethical standards, engineers rely on international heavyweights like ISO. By using precise control processes, like attribute and variable control charts, you guarantee that every single component rolling off the line meets exact global specifications. All right, let's render our final interactive quiz for this explainer. Think back over Module 3. First, who holds the keys to your professional registration in Malaysia? Next, what legally protects your engineering inventions? And lastly, what does OSS stand for? Let's see how you did. BEM and IEM are your regulators. Patents protect your inventions. OSH ensures you keep your workers safe. That's occupational safety and health. And ISO governs international quality standards. Nailing these proves you really comprehend the vital legal codes and standards expected of you. Now, zooming back out to our university blueprint, we're looking at the BX 1303 course learning outcomes. Everything we just explored maps perfectly to these 4 pillars. By mastering ESG impacts, applying the design process, understanding BEM and IEM, and enforcing ethics and safety laws, you aren't just memorizing a syllabus to pass a test. You're actively constructing the mindset you need to solve incredibly complex engineering activities. So, as we power down today's 3D explainer, I want to leave you with this to ponder. When you finally get that PEN license, will your future designs merely function to make a quick profit, or will they truly elevate society and protect our planet? The blueprint is entirely in your hands.